Sultan Mayaki, and I'm senior consultant with Valiantys. Today I'm going to talk to you about what is the best configuration to run Jira Data Center. Most of the things I'm going to say has already been mentioned by the previous speaker, but I'm going to go more and more, and then we discuss some of our experiences. So what we are going to talk about today, we are going to talk about the history of Jira Data Center, so that we can appreciate more and more of the functionalities that we get from data center and the benefits that it has to offer. Then we're going to look at when to consider the move to Jira Data Center. We did a lot of experiments, so I'm going to share with you our study mission, how we set up our environments, the test campaigns we ran, the technical environment, the little tunings we had to do because along the way, because we are trying to do some test Jira to kind of the limit, right? Then we share some results and the key findings. Now, history of Jira Data Center, as you know, Atlassian started in 2002, and the premier product there was Jira. By 2008, the latest version of Jira was already 3.13, and at that point in time, there is a bit of issue whereby you can't go beyond 200,000 issues. Going beyond 200,000 issues causes a lot of panic, and Jira couldn't handle that much. And what is the solution for enterprises? Enterprises end up splitting Jira. I still remember some customers having like multiple instances, and they need to link them together, and sometimes finding information from one instance to the other is a hassle. Another solution that enterprises usually use is archiving the Jira projects, all projects, so that they can still live within the limit of 200,000 issues. Now, and a partner within the Atlassian marketplace came up with the clustering solution. They call it Scarlet at that time. Now, Scarlet was a great tool, but then it has another issue, because with every upgrade of Jira, then there comes the issue of maintenance. Maintenance becomes an issue. So basically, when you're upgrading Jira, it's like you have to rebuild the solution just to support the API changes. So it was a pain. Now, in 2012, Jira 5.1 was released, and it comes with a lot of improvement in terms of performance. And the issue log on 200,000 was kind of lifted, so you can have more than 200,000 issues. So enterprises are happy that, okay, we no longer have to archive our projects, but then how about the performance? What happens when we go beyond millions of issues, right? So, and Atlassian is aware of this kind of concerns of customers. So in 2013, Atlassian started the Blue Label project, and with the sole goal of coming up with a clustering solution. So we have the Jira on cluster of active nodes, and because of that, we can spread load across different nodes so that we can have better performance, and we can have high availability and so on. And then one of the key feature also, we can have instant failover basically. So when one node is down, users can be redirected or rerouted to another active node that is working. So just now someone asked a question about is it possible to have, if you are not using data center, can you have two nodes or active to active nodes? Yeah, so some people usually use what we call the cold failover, whereby you can have two nodes, but they're not actually active to active. They're all, one has to be offline, and one has to be online. And then, so whenever there's a problem with one of the nodes, you need to kind of have a downtime, which is enterprises. For enterprises, this is a big issue. So that's why Jira Cluster is a big thing. So I'm sure by now we understand the benefit. And from 2013, Atlassian keeps improving the Jira Data Center, and more features keep coming to Jira Data Center. As we talk about later, right now, as she mentioned earlier on, we have the Jira project archiving, which is coming up in 7.10 of Jira. I just saw it on the early access release. So yeah, Data Center keeps improving. So now this is Jira Data Center. Now, when do we actually need to consider the move to Jira Data Center? So one of the requirements, also, like I said, my slide keeps kind of repeating what she said earlier, so uptime requirements. So if you want to minimize planned or unplanned downtime, switching to Jira Data Center is actually a good option for you. This is because whether the downtime is caused by application issues such as JVM errors, database connections, or bottlenecks, right? Then it's not longer a big problem. You can actually bring down the node, and then users will get rerouted to the next available active nodes. So uptime is no longer a very big issue for you when you move to Jira Data Center. As mentioned also, concurrent users. When you have more and more users hitting Jira at the same time, traditionally on a single node server, you will notice degradation in performance. Jira, the response time becomes more and more behind. Yeah. All right. So another possible reason why you should move to Jira Data Center is when you notice high rate of issue creation, when you envisage that in the next few months we are going to hit millions of issues, basically, you begin to see that your Jira is growing day in, day out. Then, because with every issue created and every actions on Jira, like moving tickets, like workflow transitions, history of Jira tickets, all these things are stored in the database and the cache as well. And when the number of issues keeps growing, performance starts to creep in. And that was why, I believe in the old versions of Jira, we had that issue log. So high number of issues is a signal to start thinking about Jira Data Center. And Atlassian has provided us with a way to test this even before making the right decision. And that's why we have, Atlassian has a partnership with AWS, with CloudFormation, whereby you can, with a click of a button, you can spin up Jira Data Center. You can load it with data that looks very similar to yours, and then you can kind of do some testing. Even they have the testing framework within the AWS, so we'll come to that later. Now, sometimes it could be that you have all the health checks working perfectly, and you are using the right platforms. That means, you're using supported database, your JVM you're using correct JDK, everything is supported, but then you notice most of the time your server is getting, is kind of having performance issues like the CPU spikes and memory. So this is a signal that basically your server, one single node couldn't handle the load. So it's time to start thinking about a move to Jira Data Center. This is actually, I just added this just yesterday. Then I was reading about the 7.10, about the archiving feature of Jira Data Center that is coming soon. So this is another good feature that allows you to take away some projects, old projects that you don't need them anymore. As I mentioned, all these issues and projects are actually under index. So when you take them out of the index, they are completely removed from the index, and then Jira gains lots of performance. All right. So our study mission, what we try to achieve here is we try to find out what are the bits and pieces, what are the best configurations to use on Jira Data Center. So we did some tests. I don't know how many of you have read our white paper before, the 10 million issues white paper. We wrote like 1 year ago, something like that. So we did a test on whether Jira can handle 10 million issues. So what we aim to do in this particular research is basically to find out other factors, like the number of nodes based on certain category, based on the size of your issues. We also try to look at databases. We did the same experiment with different databases, Postgres. We'll talk about that in a second. We also look at different OS that enterprises usually use. And now, what is the behavior with increasing configuration and number of issues? So this time around, we're not actually looking at the number of issues alone, but we're also looking at configurations. What happens if your number of issues grows from 100,000 to 2 million, and the configurations also increase, your number of permission schemes, your security level, your number of custom fields, all those kind of configurations. So we try to put those factors together. And now we also tested the CloudFormation template. This was if you are actually trying to transform from single node from Jira Server and you want to move to Data Center, most of the time you might be using CloudFormation template as a proof of, like kind of a proof of concept, test things out before you make the decision. So we try to also make a test on the CloudFormation template. So we came up with our setup scenarios. We came up with based on our own experience and working with different customers, both enterprises. So we came up with this kind of scenarios. So our aim is to test, you see the first row, the second row, issues. So we are testing scenarios. Scenario 0, we are testing 500,000 issues. Then scenario 1, we are testing 1 million, 2 million, 4 million issues. And if you look at the leftmost column, are all the different variables we are changing. So because we anticipate that when your number of issues grows, your configuration also grows as well with that. And we keep the concurrent users at 1,000 across the scenarios. So we wanted to test what happens with 1 million issues with 1,000 concurrent users, for example, all hitting the server at the same time. So this is our setup scenario for this experiment. You will notice the number of custom fields here. We made them all to be global context. This is, again, we are trying to stretch Jira to the max. In real life situation, you don't put all the custom fields to have global context. And we put all the custom fields actually on the issue operation screens as well. So whatever figure you see here, in real life scenario, you might expect something less than that. Because here we are actually pushing Jira to the max. Yeah. So we did several campaigns because we tried to determine what happens with increasing number of nodes on Jira Data Center. So we started with 3 nodes. Then we tested with 4 nodes, 5 nodes, and 6 nodes. Now, in the 4 nodes test, because we had some hypotheses also, so we had additional tests on the 4 nodes. So we did the first test of 4 nodes without even though we have issue security levels, so we don't associate issues with security level because we believe that security levels has lots of performance implications on Jira. So, so the first test we did is, okay, we have the configuration security levels, but we don't associate the issues. And then the second set, we have all the issues associated to the security level, and we try to gauge the response times, right? So the next test we did was we tested Jira Data Center on Windows and on CentOS. And by the way, all our experiments we did on AWS, right? We didn't test on bare metals, so we did on AWS. We also tested these databases, Oracle, Postgres, MySQL, and SQL Server, right? Then we did the campaigns on the sizing. So as you remember, I think this rings a bell looking at the previous table we saw. Now, as I was talking about CloudFormation with AWS, and there is also kind of a template with Azure, but we just focus on AWS. So we did the CloudFormation template. We tested how it works really. So basically, it's a template that allows you to spin up Jira nodes within the same VPC, and the shared home is basically using the Amazon EFS. So in our previous tests that we did before the CloudFormation, we also used the same EFS for our shared home as well. So everything is within AWS. Just that we wanted to test this particular template. Now, in terms of the technical environment, this is how our environment looks like. So we have HA proxy at the top as our load balancer. We have the nodes, and then we have the database, and shared home is EFS, which is kind of very optimized service. And now the JMeter, we use JMeter to run the test, and we put the JMeter script on a separate server so that it doesn't interfere with our actual test. Now, before we started this test, we did additional tunings. As you know, we are trying to do a lot of, we try to put a lot of data into Jira Data Center. So we had some issues from the beginning, and one of the things we did to fix is like we had issues about the index optimizations. So the index log timeout by default is in Jira is 30 seconds. So we had to increase this to 90 seconds because some issue when creating issues or updating issues, we used to have like a log timeout. So we increased that a little bit. The index threads, this doesn't affect the test actually, but just to make us move faster. So when we do a particular test, because we usually recreate the environment and we rebuild the index, so it was taking longer time. So we increased the number of threads, the indexing threads from 20 to 50, just to make things faster. One thing we did also, we had to disable auto backups so that when we run the test, we don't have any interference from external services, like that. And then now this is an interesting part, increasing the memory of each node. When we started, we tried to give a conservative figure. We started with like 8 gigabyte with 4 million issues, and you have seen our configurations. And we had an issue whereby it becomes to have a lot of OOM issues, very frequent, because we don't have any standard to use. But for your case, if you are coming from Jira Software, you want to move to Jira Software Data Center, you already have your own server, you have history, you know how does it perform during non-peak time and peak times, so you can have an idea of the heap allocation. So for us, we had to do a bit of tests, and then after a while, we come up with this number, because that was when Jira begins to have stability at 4 million issues. So yeah, this is kind of, the next one is kind of standard. Governance, we need to enable GC logs and heap dump so that we can review when something happens with the test. And we use a G1 GC collector based on Atlassian best practice. I think Atlassian has a document about tuning the performance, so we just followed those guides. And this is particular for Unix systems. The number of open files is limited, so we had to increase this number so that the number of files that can be opened by the Jira process. Because if you cannot open more files, more file system, the performance Jira begins to have degradation of performance. Some actions cannot even be completed, like creating issues. So we increased that from 4096 to 8192. So I believe by default is 4096. Now, in terms of the test actions, Jira, there are several actions you can run on Jira. A project manager has different set of actions they perform on Jira. A Jira admin has kind of a different actions they perform. Like a Jira admin usually creates users, role membership, all those kind of stuffs. But what we try to focus our experiment on day-to-day users, what normal users usually do. So we try to, in our experiment, the script tries to mimic when a user logs in, view dashboards, view Kanban boards. The Kanban boards here, we put like every column of the Kanban board to have 1,000 issues. I think this is not a normal scenario. This is too much. So this is, as I said, is just trying to do stress analysis on Jira. We also do search. So basically users search, and we also search patterns basically. search for a particular string in the Jira issues, like searching the summary or description for a particular string. We also search issue types. Like say, I want to find issues that are stories or epic. So we try to do that. And then users try to create issues, and then users try to comment on an existing ticket. So these are the actions we scripted in JMeter. Now we are going to look at some of the results we got. So I'm going to pick, because the result is, because this is a slideshow, so I'm gonna zoom out one particular action and then I show you the overall results. So this is the test we got. So you can see with 3 nodes, the performance was really struggling. So when we added more nodes to 4 nodes, we got a better performance. And with 6 nodes also, with 6 nodes and 4 nodes, we didn't see much of a difference. But 5 nodes, we had some kind of anomaly. One of the things that could happen was because index replication between the nodes kicked on at the time we were running the test. So we didn't actually try to do it again, but we kind of have an idea of what's happening. So when you can see with 3 nodes, it was bad, and then with 4 nodes, it got better, and with 6 nodes, there was not much of a difference. So at that point, we know that, okay, with 4 nodes is the kind of better for us. And this is kind of things that's why Atlassian you can do with CloudFormation to determine for your case. And this is the overall results of all the actions and the response times. Now, yeah, as I was mentioning to you, when we did the node analysis, we also tried to test our hypothesis that security levels has significant performance issues. So we did the test with 4 nodes. One has all the issues with security levels associated to the issues, and one without the security levels. And the results is quite, you can see it's almost like 70 to 80% better performance if you do away with that security level. But that is not saying that you shouldn't use security level. You can use security level, but with lots of governance. And I believe one of my colleagues will talk after this, he will talk about platform governance. So it's not that everything should be used, you should use security level. It has to go through some kind of change management. You need to go through a lot of discussion to find out. And you don't create security level for all the projects. You know, there should be some certain projects that should be associated with the security levels. And this is the overall results. Yeah. So we did the OS centric as well. Here I must say, as I said earlier, we are using AWS. And AWS for the shared home, we use AWS service called EFS, which is highly optimized. The IOPS is very good, and that's what we believe actually affected the result was because the shared home was using the EFS, whereas in Windows, the EFS is not compatible with Windows. So what we had to do, we just created EC2 instance, right? And then we used Samba to mount the files. So we use it as a shared home. So that is one factor. Another factor is that we didn't do any tuning on the OS, or we didn't try to disable any functionality of Windows, for example, the antivirus and so on. Ideally, we can do something like restricting certain directories that the antivirus could scan. So we didn't do all those kind of activities. So this could be when you do it properly and you use the difference shouldn't be much of a very big. So I'm just trying to give the caveat here. And this is the overall results. The database, in terms of the database also, all the database are running on AWS using the RDS service, and we didn't do any tuning. The reason being that most enterprises have dedicated DBA administrators that tune the database. So what we try to do, we try to see what comes with the vanilla databases in AWS, and we run the tests and we measure the response times. So this is something also with a good DB administrator, things could get better with the rest of the databases, but overall there is not much difference if I show you the overall results with all the actions. It's not that it's kind of marginal. Now the big difference is with the sizing. I must warn you before I show you the results. When you look at the table we gave earlier on, with every scenario, like when we move from 0.5 million to 1 million to 2 million to 4 million, we almost doubled the configurations. But this is not ideal. In most scenarios, you shouldn't double your configuration just because the number of issues is increasing. We just try to put it at max, and if I told you the custom fields, all we have are global context. But even though it shows that when we move to 4 million, it grows very fast, but then the response time is still within 5 seconds, for example, to view the Kanban board. Just that it was very good with 0.5, 1, and 2 million. And just overall results. And then we tested the cloud formation. We use our own script, the JMeter script, to run the test on cloud formation. But Atlassian has what we call the E3 performance kind of a script for you when you're using the cloud formation, basically. So you can run the E3. So because for consistency, we use our own JMeter. And what we found out that there was no much difference between the performance when using the cloud formation and our own setup, basically. So that's what we are trying to prove here. So in terms of the key findings from what we can say is that the best performing, the number of nodes that performed better was with 4 nodes. And when you keep increasing the number of nodes, it comes a time whereby adding more nodes doesn't have much of a performance improvement impact. So for example, if you're having 2 nodes and you're having lots of performance issues, increase it to 3 nodes, you will get a better performance. And when you go to like 4 nodes, you still can get a better performance. But when you keep adding nodes just because you are growing, there comes a time when it becomes kind of stable, and that it doesn't change much. As I said, with caveat that we use the EFS for CentOS, and it has better performance when using the Windows. Database has little performance impact, especially when you have a good DBA to tune it. The cloud formation doesn't differ much from the baseline. There's importance of identifying the optimal heap allocation. So if you are trying to move from your current Jira Software to Data Center, this shouldn't be much of a hassle for you. But for us, we had to face this issue. So the negative impact of security levels on performance is something we need to echo. Performance degrades with increasing number of issues and configurations, so you need to do governance. Governance is a very important thing to do when you begin to grow. And I should have added something here with the project archiving. Also is a good feature to improve the performance when you're growing. And I think that's just what I'm trying to share with you about our experiment, because we really love the Jira Data Center, and we always want to measure the performance and be able to help our enterprise customers.